Hello guys, this is Nehal. So today we are going to cover some hard questions from Cambridge IGCSE 0478. So this video is for paper 2 and this specific question paper was made by figuring out which questions were hard from the exams. These are the questions where students do mistakes or they get it wrong, they miss some points, or they do not answer according to the context. So this document was made by reading the examiner's report. So if you don't know what the examiner's report is, this is a document where the examiners and the checkers comment on specific questions of the students and they identify where they made mistakes or why they made mistakes. So we are going to cover this today. Let's start. So since this is the last day for most of you, I'm going to go a bit fast and I am considering that most of your preparation is done. So the first question. A telephone number with 13 characters is input. The first character is a plus followed by a 2-digit country code. For example, plus 20 and we have a bunch of X where 20 is the country code and X is a digit between 0 to 9 inclusive. Alright, so we know that every character will be from 0 to 9. The algorithm includes checks for country codes 44 for UK and 20 for Egypt. Write an algorithm using pseudo-code to input the telephone number, extract 2-digit code, output the matching country, output unknown if there is no matching country. Alright, so starting off we will take an input from the user. So let's say input will be capital, right? So we have input followed by the name of the variable. So let's name it telephone. Right, see here we are not asked to prompt anything, so we can just write this without any prompt. If there was any prompt written, we would write output and we would write something like please enter a telephone number, right? Then we will find the specific part of the number. So here this part, right? This means we will take two characters starting from the second character, so we will use the substring function. So let's say val is going to be set to substring. We will use the variable here telephone. Then we are going to mention the number of the starting character, right? So we have plus 20xxx. So the index of this is 2, so we add a 2 here and we are going to take two characters from here, so we are going to give another 2 here. All right, so value is equal to substring of telephone and 2. Now we are going to match this. So if this value is equal to, we have at first we will check 44 for UK. So if this is equals to 44, then we'll output the matching country. So we will just output UK. Right, now going to the else operator, we will now check another thing if this is 20 or not. So again if statement, if value is equals to 20, we are going to output Egypt now. There will be then here. Ideally then should be in this part. All right, if and else will output unknown. So we have if here, we should add an end if here. We had a if here, so we should have an end if here. All right, next question. Explain how you could change the algorithms to repeatedly prompt for the telephone number until the number entered is 13 characters in length. Any code used must be fully explained. So basically the way the operation works, we will take an input at first, right? So then we will check a while, we will use a while loop or something. So using the while loop, we will check if this is 13 characters in length or not. If this is not 13 characters, we will again take a input. All right. So we'll keep on doing this until the while condition is met. So after this is done, we will then accept the input. So at first check the length of input. Use a while loop to check the condition. Take a input from the user. Check if the length is 13 or not. Use a while loop which will run as long as the length is not 13. Inside the while loop, it will again. All right. So next question. All right, coming to the next question. An algorithm has been written in pseudocode to generate a random integer between 1 and 100 inclusive and store the value in n. The user enters a guess for the number and the algorithm indicates whether the guess is higher or lower than a random number. The algorithm outputs the number of guesses when the user has correctly guessed the random number. Identify the line numbers of the 4 errors in the pseudocode and suggest the correction for each error. So in this code, we are going to assume that the declaration is already done. All right, that won't be counted in the errors. All right, so let's analyze the code now. So we have a counter set to 0. I guess this will count the number of inputs. All right, so then n is going to be set to round random in multiplied by 99, and we have a 1 here plus 1. All right, so we are supposed to get a number between 1 to 100 inclusive, right? The random operator, this gives a number between 0 to 1 inclusive. If you multiply this by 99, then we have a range from 0 to 99, right? So this is round operator. The 1 here indicates the number of decimal places that we should have. So here we are going to need an integer. That means this is a whole number, so there won't be any decimal places. So this value should be 0. This will be set to 0. All right, then we are going to add 1, so the range becomes from 0 to 99 to 1 to 100. So we are going, this is the first error, which is in line number 2. The value should be given 0. All right, next repeat output, please enter I guess input if g is greater than n. So g is greater than n. Alright guys, I'm going to use this step because that question had a specific problem where some operators were not given. For example, g is greater than n, this g was missing or else was missing. So it was there was a bit of issue while making the question, while copying the questions actually. Alright, so let's see here. If g is greater than n, then output the number is lower than your guess. So the g is our guess. Alright. Else, if g is less than n, that means the number is lower than your guess. So here we are given two lowers. That shouldn't be like this. So if g is less than n, that means the real number was higher than our guess, right? So this should be higher. So the another error is in line number 12. We need to fix it and write output the number is higher than your guess. Alright. Now end if. Then we increment the counter. Counter is going to be set to counter plus 1. Again end if. So there is a problem here. After else we wrote this statement, right? This part of the code shouldn't be here. This should be after the end if statement. So this is another error. So this should be line number 14 should be executed after the end if statement. All right. then until g is equals to n, then we output well done, you took guess attempts. So guess is the value that we were guessing, right? This is the value that we input, but this should be counter. All right, so we need to answer it accordingly. Line number 2, 12, 14 and 17 had errors. So let's write it down here. This should be line number 14. Correction, this should be placed after line 15. For the other mistakes, you should just write the updated line. So this line should be the number is higher than your guess. All right, going to the next question. All right, in this question we are given a flowchart. So start input. Now let's see the question. Complete the trace table for the algorithm using the input data of 21, 46, 63, 91 and 12. So let's trace this. Let me bring a new tab. All right, so here we have the trace table and here we have the flowchart. So at first we have a value of 25. So using the flowchart, we see that we are going to start and then we are going to input score. So this value of 21 should be stored in score, right? Then we check, is this score greater than 40 or not? We check this, is this score greater than 40 or not? This is not greater than 40, right? So we go to the no operator. Then we check, is this greater than 60? That is also a no, right? So then we check, is score greater than equals to 80 or not? That is also a no. So we go to this operator where we said grade is going to be set to D. So here we are going to set D. All right. Then we output, you achieved the dash grade. So here we write, you achieved a D. All right. Then this is done. All right. Then we go to the stop operator. So here we have a slight problem that we already filled up one row and we have reached the stop operator. That means this part of the inputs are not given, right? These are not executed. All right. So this is a very weird thing for the question actually. So they will actually give you the full marks if you only write this. All right. Also, another approach is you take this one, you run the algorithm once with this input, then you run the algorithm again with 646, then 63, 91 and 12. All right, so you basically run the whole algorithm 5 times. They will also give you marks for running this 5 times. Both of them will allow you to get marks. All right, so let's just keep it like this. Explain how the flowchart can be changed to produce the correct output. All right, so here we gave an input of 21 and we got a D. That was actually right. So to explain this, let's actually try to work with the other inputs too. So if we have a 46 here, we check, is score greater than 46? That is true, right? Then we give a grade of C and we give a same output of C. All right, but C here. Then we again run the operation. All right, so after giving C, we basically go to this part and output, right? And the algorithm stops. Then we run again with the value of 63. Here we check the first statement and again we are giving output of C. So we are giving you achieve the C. All right, then again we run using 91. Using 91 we again get a C and we write C here. Then again we run this using 12. For 12 we check it is greater than 40 at first or not. Then we check this, then we check this, everything will turn no, and then we output D. All right, so we output a D here. All right, so explain how the flowchart can be changed to produce the correct output. So here's what happened. We were checking if the score is greater than 40 or not, right? So here we are checking at first if the score is greater than 40. If it was greater than 40, then we outputted C. All right, So this should be the other way around. At first we should check if the score is greater than 80 or not, then we will check if the score is greater than 60, then we will check if this is greater than equal to 40 or not. So we need to change the decision boxes. All right, so if we write 80 here and we can write 40 here, we should also change this should become A, then we check for B, then we check for C. All right, so these are the four changes you can write. So explain how the flowchart can be changed to produce the correct output. This is one way. Also, Cambridge gave another mark which is for looping. Here we ended the code whenever we found a grade, right? But this should continue ideally. So basically the arrows should lead to this part again. So all the arrows here, this one, this one, this one, and this one should actually lead to here. Alright. Or then if the score is equal to -1, we will go to the output. All right, so any of the set of answer will work. So here let's answer using the if statements. All right, so we update first decision box to check score greater than equal to 80. If yes, set grade to A. All right. So then we update third decision box. By decision box I am meaning this selection statement to check score is greater than equals to 40. If yes, set grade to C. Right, this is good enough. All right, in the next question we have May June 2025 variant 22. So the problem in this question was that this question was actually removed from the paper because it asked for something that wasn't in the syllabus back then. All right, but this thing is now in the syllabus. It has been added. Basically for one of the operator you needed 3 inputs. All right, in a procedure you needed 3 inputs, for example here, but it has not been given in the syllabus back then, so this has been removed. We will do this question at the end of the video. Now coming to the next question. For this question Cambridge actually gave everyone full marks, 15 out of 15. All right, coming to the next question. All right, this is the next question. The purpose of this pseudocode algorithm is to carry out a bubble sort to sort in descending order 1000 numbers stored in a one-dimensional array. Identify the line numbers of 4 errors in the pseudocode and suggest the correction for each error. Right, so let's see this part. Declare values 1 to 1000 of real. So this is okay. We are setting an array of 1000 elements. Then we declare index of character. So usually index is not set to character. This might be an error. Let's see how index is being used. So we are setting index from 1 to 50, right? So this should be a integer. All right. So this should be integer. All right. Whenever you answer, you should write the line number error and you should write the answer. It should be, then you write the whole statement. All right, declare index and we set integer here. All right, then declare stop. This is going to be set to boolean. All right, declare hold of real. Stop is set to false. While not stop do, then stop is set to false again, and stop is also set to false again inside the bubble sort, inside the swap statement, right? So that means stop is actually denoting if any swap has been done or not. All right, So here we are running while not stop. That means it is acting opposite to the swap statement. So this should be set to true. This should be set to true. So if any swap is done, that means stop will be false. If no swap has been done, that means stop is going to be true. So we should set true here. All right. Then we check for index. This is the error, line number 7. This should be stop is set to true. All right. Then we check for index 1 to 50. If values index plus 1 is greater than values index. All right. But here we are given 1000 elements, right? So this should not be 50. This should be 999. All right. So this is another error. This should be 999. This part. Alright, if values index plus 1 is greater than values index, then hold is set to values index. This is acting as a temporary variable. The hold values index is set to values index plus 1. So this is performing the swap. Values index plus 1 is set to hold. Then stop is being set to false. Then we have end if and next index. Alright, and we have a next stop here. But this is a while loop. In while loop, we don't use next statements. We use this whole line should be written as end while. Alright, you should write the updated parts in this answer. Alright, continuation with the question. The subsection in line 11 to 13 of the existing code are to be changed to a call statement for a procedure. This procedure will include two parameters representing the index of the array elements to be swapped. Complete the pseudocode procedure for swap. Alright, so this should have some parameters. Then we declare hold of real. Hold is going to be set to values. We need two index here basically, right? So we have index 1, let's say I1 and I2. All right, then we are going to perform a swap where in the values array we are going to swap these two indexes. This is I1. Right, so this value will be set to here and this value will be set to here. So while doing this, we will have a temporary variable. We will name this hold. So I1 will be set to this, then we set I1 to I2, then again we set the value from temporary variable. All right, so we basically need two indexes. So two parameters represent the index of the array elements to be swapped. So let's say index 1, this is of type integer. Index 2, this is also of type integer. Declare hold real. So hold is being set to index 1. All right, so this is the first element, index 1. So let me explain it again. What's happening is, let's say this is hold. All right, so the value of first index will be set to hold, and then we are going to set I2 to I1, and then we are going to set I2 to hold. So now we write values index 1 is going to be set to values index 2. All right, now we have values index 2 is going to be set to hold. Write the pseudocode to transfer control to procedure swap. So we are supposed to call swap here, right? So instead of this specific part, we just call the function, call the procedure. So we write call, the name of the procedure is swap. So instead of index, first index, we give index plus 1, and index. All right, so here we write index and index plus 1. So here the operation, the order of this variable, the parameter doesn't matter, right? Because we are in the end swapping this. So this can be the first parameter, also the second parameter. Right. Explain the difference between global variables and the variable declared in 3bi. So here inside 3bi, this part. So this is a local variable, right? So this is not a global variable, this is a local variable. So we can write global variable are used throughout the program. The variable in 3bi, also basically the whole variable is a local variable, and it can only be used inside the procedure. All right, let's go to the next question. So there were not really any question from February, March 2025 that was significantly difficult. All right, next going to October, November 24, variant 21. Describe three methods that are used to design and construct a solution to a program. All right, so in this question there are actually many possible answers. You can give procedure, then basically modularization, then structure diagram, flowchart, pseudocode. These are all accepted. All right, so let's write the safest answer. So we write with flowchart. Method one is flowchart. Right, so flowchart, it's a diagram. So basically flowchart, a diagram showing the order steps to complete a computer program. Then in method two, so structure diagram, a hierarchical diagram showing the breakdown of a computer program into subprograms. And then pseudocode shows what a program does in plain language. Next. All right, then we have this question number 6 from the same paper. An incomplete algorithm has been written in pseudocode to count the number of zeros stored in an array and total the non-zero values. All right, so we basically count the number of zeros. This count will represent the number of zeros. All right, zeros, and total of non-zero. This is basically sum, right? We are doing the sum. Right. Declare C integer, I integer, T integer. These are going to represent, I guess, the counter. This is the counter or the count. This might be the index and T might be the total. Right. We set I to 0. Then we have line number 6, which is empty. Then we have for C 1 to 50. So C is basically representing the index. All right, this is representing the index. For C 1 to 50, if A of C is equals to dash, we increment. So what are we incrementing? We are counting the number of zeros, right? So that means we will check if this is equals to 0. If A C is equals to 0, then we will increment T. So basically T is representing what? The count. The count. Alright. And then we have at last we have for, so we will have a next, and the name of the variable here is C. So basically we are setting T is equals to T plus 1, but we didn't initialize T, right? So we will set T to 0 here, and T is representing the sum or the total. Sorry, I, we are actually summing the I, so I will represent the total. Right. Write the pseudocode to display with suitable message the number of zeros stored in the array and the total number of non-zero values. So we'll just write the output of these variables. So we have output. The reason the question is 3 marks is because we have to identify exactly which variable has been used, right? So we will write output receivable the number of zeros, number of, you should actually, whenever you are going to give an output, you should write in full form. I'm just keeping it short to keep the video short. So we are going to write T here, then output, and the total of non-zero. Total of non-zero, and using comma we write the variable I here, right? Total of non-zero means this one, right? Total. This is I. Alright, next question. Meaningful identifiers have not been used in the algorithm. Suggest suitable meaningful identifier for the array. So we can just name it anything actually. This array, let's say. Then T, C, and I. We already wrote this. T is count, C is index, and I is total. Alright. So T is count, total, index. So T is count, C is going to be set to index, and I is total. Alright, let's go to the next question. So, a shop that sells cheese has set up a new database table called cheese stock to store details of the cheeses available for sale. Part of this table is given. Question D1. Complete this SQL statement to display only the name of all cheese that are out of stock. So we need to represent out of stock here. Alright. So here we are given ch number, which is the primary key, then name in stock. This actually represent if this is in stock or not. We check if this is yes or not. Alright. Then we have supplier code, price per kg, and weight of kg. This is the total weight. Alright. So if something is not in stock, if this is not in stock, the weight is going to be 0. If this is not in stock, the weight is going to be 0. If this is not in stock, the weight is going to be 0. So we can check either of the operation, either of the value, right? So we return the name only. So we will select name from here. So we have select name. So we have select name, then the name of the table is cheese stock, and where it is not in stock. All right. We can also check weight kg is equals to 0. We can also write in stock is equals to no. Explain how one of the lines in your statement in part D1 could be changed to display the same information. So exactly what I just discussed, we can write where can check if in stock is no, or if weight kg is 0. Any of this works. Alright, so coming to the next question. This pseudocode represents an algorithm. An input of -1 will terminate the algorithm. So we are going to complete the trace table with the input data given. So we have the algorithm in the right part, and this is the trace table. So starting of the, if we start the algorithm, so if we start the algorithm, we at first declare, all right, this is done. Then we have repeat. We take an input. So we take an input of value. So this 5 is going to be set to value right here. All right, this is done. Then we have count. All right, if value is not equals to -1, value is not equals to -1, then answer is going to be set to value. So this value, this answer is going to be set to 5. All right. Then for count value minus 1, so value minus 1 is equals to 4. So we start count from 4 and we repeat till 1. So we will repeat till 4 to 1 inclusive, and step is minus 1. All right. This is going to be minus 1. Answer is equals to answer into count. So answer is equals to 4 into 5, which is 20. Next count is going to be set to 3 because we are going to do a minus 1. Then answer is equals to 3 into 20, which is 60. Then we set this to 2. Answer is 2 into 60, which is equal to 120, and this is 1. Answer is equals to 120 into 1, which is 120. When we are done with this loop, then we output answer. So the output is going to be 120. End if until value is equals to minus 1. So value is not equals to minus 1. So we take an input again. All right, this time we are going to go to 6. So 6 here. All right, we took the input. If value is not equals to minus 1, this is true, then answer is going to be set to value. So this answer here will be 6. For count value minus 1 to step to 1. So this time we are going to go from 6 to 1 and we decrement 1 each time. Answer is going to be set to answer into count. Alright, so count will start from 6. Answer is going to be set to 6 into 6, which is 36. Alright, so let me fix this. Count is going to start from value minus 1, right? So this is going to be 5 to 1, right? So this is going to be 5 and the answer right here will be 30. Alright, then we decrement. This becomes 4. 4 into 30 is equals to 120. So we set 120 here. We decrement count again. This is going to be set to 3. 3 into 120, this is 360. Decrement count, this becomes 2. 2 into 360 is equals to 720. Decrement, this becomes 1. 1 into 720 is equals to 720. Again, we are done with the loop since we reached 1, right? So then we are going to output the answer. So the answer right here is 720. Alright. Until value is equals to minus 1. So again, we start from minus 1. We give a minus 1 here. Now, if value is not equals to minus 1, we do this. But the value is minus equals to minus 1, right? So we skip this and go to this part. And we check until value is equals to minus 1. So value is set to minus 1, so we end up program. Alright. Then, so here the operation is basically doing what? We are going to multiply every number with every preceding number, right? So that is actually what factorial does. So we can write find the factorial of the number. Calculate the factorial of a number. Describe the problem that would be caused if this algorithm if a value of 1, 0 or less than minus 1 was input. So if we input 1 in this algorithm, let's see what happens. We are not going to the so if we input 1, we are going to start with what? Count value minus 1. So value minus 1 is 0. So we are going to start from 0 to 1, right? And each time the number decreases by minus 1, right? The number is being decremented every time. So that means if we start from 1, we actually loop from 0 to 1 and this will continue forever, right? If we start with minus 1, so if we start with minus 1, the algorithm will stop. All right, if we start with 0, again we reach the same problem. Or if we give a value less than 0, less than minus 1, we again reach the same problem of the infinite loop. All right, the program would accept the value and enter the for loop. Value would keep reducing by 1 and would never reach 1 as it would already be less than 1. So there would be an infinite loop. All right, next question. One stage of the program development life cycle is the analysis stage. Identify and describe two other stages of the program development life cycle. So in a program development life cycle, we have 4 stages, right? We start with analyze, then we go to design. After design, we have coding, and after that, we have testing. All right, so we are already given analysis here, so we need to mention either design, coding, testing. If we mention design, we write that we use a standard method like flowchart or pseudo-code. All right. In design, we write the expected values, or we can do that. We basically construct the solution. Then inside coding, we write the main program. Then we have iterative testing that might take place. We use a programming language or something. In testing, we write the program is tested for errors. The program is checked if the requirements are met. So let's answer this. All right, basically design construction of solution using standard methods. These include flowchart, structure chart, pseudocode. Then coding program is written according to the design. Iterative testing takes place. All right, next question. An incomplete algorithm has been written in pseudocode to count the number of values stored in an array and to find their average. Values have been stored in the array starting from A1. All the values to be counted are non-zero. A value of 0 in the array indicates there are no more values stored. Right. So here the names are very weird because we are only using a letter. So we have an array where values are stored. We can name this as values. Alright. Then we have declare C, declare W, declare X. So values have been stored in the array string. All the values to be counted are non-zero. A value of 0 in the array indicates there are no more values stored. So we have C, W, and X. Alright. So we are setting W to 0, then C is being set to something. While C is not equals to 0, we are doing an operation with W. And C is basically representing what? The index, right? We are looking through the array because we are using C here. So we will start C from 1 because this is the index. Alright, so C is set to 1. While C is representing the index. Alright, and while X is being set to something, and increment algorithm has find the average, right? So we need to find the average of the numbers. So the formula is what? We divide the total the average. So this is actually the average. So if this is average, W will represent the total since we sum this up. So W is equals to W plus the array element, right? W plus array element, which is AC, and X is being set to the total number of values, right? So if we have an array, let's say 1 5 6 0 0, for the average we will count only 3, right? So here when we use the loop, C is being set to C plus 1, meaning the value of C will end here, right? So for average we actually need C minus 1. So we write W, which is total, divided by C minus 1. In the mark scheme, you might see an answer where round is given, but it is not really necessary because it was not mentioned in the question. Write pseudocode to display with suitable message the number of values stored in the array, the average of those values. So this is very similar to the previous question that we did. So output the number of values stored in the array is C minus 1. So usually students miss this part, C minus 1. Output average of non-zero elements in the array is X. Alright. Then meaningful identifiers have not been used in the algorithm. Suggest suitable meaningful identifiers for the array, the variables. We already did this here. So just write the names in this answer. Alright. A programmer is testing a program that triggers a positive value between 1 to 100 inclusive to be entered. The range check in the program is to be tested. Identify 3 different types of test data to be used. For each type of test data, give an example of the values to be used and the expected outcome. So we have 4 possible type of test data, right? So at first, we obviously should use a normal testing. So type 1 is going to be normal. An example of a normal data will be any data within this range. For example, 2. Alright. So outcome, this will be accepted. Then we enter a extreme data or a abnormal data. Let's say for extreme we have 1 or 100, right? So let's say 1, type 2 is going to be extreme, example is going to be 1, and this will be except the value. All right, and for type 3, we can write abnormal or boundary. So let's go with boundary. Let's go with abnormal actually, and these are values which will not be accepted. For example, any value outside the range, say 101, reject. All right, next question. So an algorithm has been written in pseudocode to check that a password means a set of rules. So we are given an algorithm, then we need to trace this. So let's bring it in another tab. All right, we have the algorithm to the right, and let's draw the trace table here. Complete the 3 trace table using the data shown for each one. So data is my word. All right. So output, please enter a password, input of password. So we will set my word here. Except is going to be set to true. So except is going to be set to true. If length of password is less than 8, this is less than 8, or length of password is greater than 20, then except is going to be set to false. So this condition is met. So we write except is going to be false. Now, if L case lowercase of password, which is equals to my word, equals to password, or uppercase of password is equals to password, meaning we convert the whole word into uppercase or into lowercase and check if this is equal to input. Basically, this checks if every character is of the same case or not, right? So if this is set to true, then we set except to false. So except will be set to false. So in this code we missed a small thing. At first we had an output, right? So we could write output value here, and then we should have started this line from here instead of here to here, right? This is not a necessary condition in the mark scheme, so I skipped it. All right, then index is going to be set to 1, so we write index equals to 1. All right, found is going to be set to false, so found is going to be set to false, while not found, yeah, this is met, and except, so except is already set to false, right? So we actually skip the while loop here. If not found, this is, if not found, then except is going to be set to false again, so we write false here again. Then if except, we output accepted, else output rejected, so we output a rejected here. All right, next question. Data my word. So at first we have please enter a password, so please enter a password, so we output this here. Then input of password, the password here is m word. All right, except is going to be set to true if length of password is less than 8, which is true, or length of password is greater than 20, which is, this doesn't matter, this part is true, right? So we write except as false. If lowercase of password is equals to password, uppercase of password is equals to password, but here we have two cases, so this is not met, so this is skipped. Now we said index is equals to 1, so we have index is equals to 1, found is equals to false, found is equals to false, while not found and except is already false, so we skip this part. If not found, found is false, and so we again set except to false. If except, then output accepted, else output rejected. So one common question I get is if the value isn't changing, for example, from this line to this line, the value isn't changing, right? False is being set to false again, right? So whenever you have this, you should still write the value in the cell, right? This will make it easier for you to check. And usually in mark scheme, it doesn't matter, but you should always do it. In some mark scheme, it does matter though. All right, going to the next part, my hidden. So here we start with output, please enter password. So we have please enter password here. Then doesn't matter actually. So please enter password. All right. Then password. So password is going to be my hidden. So we have my HIDDEN. So the length is greater than 8. All right. In this part, if length is less than 8 or length is greater than 20, we write except is equals to false. All right. At first, we need to write except is equals to true from line number 3. Now this is not met, so we skip this. If L case of password, this is also not met, so we skip this. Now we set index is equals to 1. So we write index equals to 1, found is going to be set to false. So here we have not found, this is true, this is met, and except, this is true, this is also met, and index is less than length. So we have index is equals to -1, right? So length of password. If substring of password index and 1, that means we will take one character, right? So we have my hidden. Using this, we take one character starting from index. So at first we will check m. If this equals to exclamatory sign, then found is equals to true, but this is not. That means we just increment this, right? We again check. This is also met because index is lower than length of password. So the length of password is what? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So this is 9. All right. Now, if substring, now we are checking y. If this is equals to exclamatory sign, this is also not true. So we go to the next part, which is index is equals to index plus 1. So this is going to be set to 3. Again, we check. This time we check this part. So if this is equals to exclamatory sign, found is going to be set to true. Found is going to be set to true here. All right. Then we add index equals to index plus 1. This 4. All right. Now we have a found of true, so not found is going to be set to false. So that means this whole part will be set to false. This operation will not run. So now we output accepted. If not found, we write except equals to false, but we actually found it. If accept, then output accepted. So we write accepted here. All right, going to the next question. All right, write the pseudocode to use a procedure named average and that passes the values of 25 and 50 to the procedure. So this is a procedure. We will use the call operator. Call. The name of the procedure is average, and the value passed is 25 and 50. Simple as that. Outline the role of procedure and function in creating a program that is easier to maintain. So, procedural function divide the program into smaller manageable segments, making it more readable or easier to understand or easier to debug. Procedure or functions with meaningful names help to provide documentation for the program. Procedure and function may be reused. Procedure and function can reduce repeated code. Alright, next part. Write the pseudocode statement to perform this task. Accept the input of a whole number from 1 to 4 inclusive. Use a case statement to output the number 1 to 4 inclusive that was entered. Output the word error if a 1 to 4 inclusive number was not entered. Alright, so here we do not need to actually use a loop. We only need to use the case statements. Usually students make this mistake here because they are used to using if else statements and they often forget the code for case statements. So we take an input of a whole number, right? So we take input of num. All right, then we, for checking the cases, we use a case statement. We write case of, here we write the name of the variable is num here. Whenever you write case statement, we write case of, then the name of the variable. Then we check the values. 1, we have 1, we have 2, we have 3, we have 4. For these cases it will be accepted, and we have an otherwise case. For the otherwise case it will be rejected. Alright. For case 1 to 4 we output the number that was entered. So we output, we can write 1 here or num. So let's write 1 to keep it short. Then output, we have 2 here. Output, we have 3. Output, we have 4 here. All right. So otherwise we output the word error. So otherwise we output error. It's capital case. And if we have case, we should end this with an end case. All right, going to the next question. The flowchart represents an algorithm. Complete the trace table for the input data. We have some data given here, and this is the trace table. All right, so let's bring a split screen here. All right, so the main reason student does do mistake in this question is because it is just too long. All right, the flowchart is very big. Also, the trace table is very big. It has too many elements. All right, so let's start. So start input limit, right? We take an input which is 7, so we add the value of 7 here. Then count is going to be set to 1, so count is being set to 1. Input number count, numbers count. So this is the numbers array. We are going to take another input which is now 47. So we have a 47 here. Now count should be incremented to 2, so this will be set to true. 2 is count greater than limit, so limit is equals to 7, right? So now we have is 2 greater than 7, which is no. So we go to this part of the code again, input of number count. So here we take another input of 50, which is being set to the second element, so we write 50 here. Now count is equals to count plus 1, so this is going to be incremented. Is count greater than limit? This is false, so we again go to this part. So we take input of count, input of numbers count. We have a 52 here, we are going to set it to here. Then count is going to be count plus 1, so this is going to be set to 4. Is count greater than limit? Again false. We again go to this line, we take another input which is now 60. 60 is going to be set to the fourth element. Count is count plus 1, this is going to be incremented. We again check, this is false, so we again take an input, and this is going to be set to the fifth element, which is now 80. All right, then we have 6. Count is going to increment, we have 6 here. Again this is false, so we again take an input of 63, so this is going to be set here. All right, then we again check, this is again false. Then go to line number 7, we again take an input of number. All right, so this is going to be set to 70 now. All right, count is going to be count plus 1. Now this is going to be 8. So now we have count is going to be 8. We have count of 8, and 8 is greater than 7, so this is true. So that means we will go to this part. So this part of the code is done, we can ignore this part. All right, so we are now in this part. Flag is being set to true, so we have a flag of true here. All right, is flag equals to true? This is equals to true actually. So if this is true, we will go to this part. Yes, right? Flag is going to be set to false. So we are going to write false here. And again, count is going to be set to -1. You can actually write 1 here on the next line. So it's your wish. Now, is count greater than limit -1? So limit is what? Limit is going to be 7, right? So is 1 greater than 7? This is no, right? So this is no. That means we go to this part, which is this part. We start from this part. Is numbers count? So now the variable we check is actually 47, right? The value we check is 47, numbers count. Is greater than number plus 1, which is equals to 50? No, right? So that means we will go to this part and set count is equal to count plus 1. This is going to be set to true. Alright, then if this is set to, we increment and count, then again we go to this part of the code. Is count greater than limit minus 1? So count is 2, this is false. Again we go to this part. Now we check the second two elements. So we check 50, is 50 greater than 52? This is false, right? That means we skip this and again set count is equal to count plus 1. We set this to 3 and we go to this part. Is count greater than limit? Is count greater than 7? No. So again we come here, we check the next part, which is 52 greater than 60, which is again false. So we do the no statement and go to count plus 1, right? This is turning out very big actually. So if count is now set to 4, we check, which is no. Now we check the next element. Count of 4 is greater than the count of 5. So we check, is 60 greater than 80? And again this is false, so we set count is equal to count plus 1. Alright, so again we now check, so no. Now we check the next part. Now we check 80 and 63. So is 80 greater than 63? And this is actually true. So now we go to this part. Alright, so here we have swap is going to be set to numbers count. So that means swap is going to be set to 80. Swap is going to be set to 80. Alright, numbers count is going to be set to number count plus 1. That means numbers count is going to be this part right here. This is going to be set to the next element. This becomes 63, right? Numbers count plus 1 is going to be set to swap. That means this part is going to be set to 80. Flag is going to be set to true. Alright, now we have count is equals to count plus 1. That means we write a 6 here. Again we check this, no. So we check this part. Now we check 80 and 70. So is 80 greater than 70? And this is true. That means we perform the swap again. We set swap to num count. So swap will be set to again 80. Alright, now number count is equal to number count plus 1. So this is going to be set to the next element. This is going to be set to swap, which is 80 now. Flag is going to be set to true. Alright, and count is equal to count plus 1 is 7. Is count greater than 7? So this is no. If this is alright, so this is no. Also you need to check limit is 7, so this should actually be 6. Alright, so now since the value of 7 is given here and this is met, this condition is met, we go to the yes part and then we go to this part, which means starting from here again. Now is flag equals to true, so we have a value of true in flag, right? So now we set flag to false. We set flag to false and count is equals to minus 1. Alright, count set to -1. Alright, now we check this again. So now limit is 6. Alright, count is start from 1. So is num count greater than number plus 1? So we compare 47 with 50 and the answer is no. So we increment count. Now we check the next part, 50 and 52. The answer is no. We increment count. Then we check 52 and 60. The answer is no. We increment count. Then we check 60 and 63. The answer is no. So we increment count. Now we check 63 and 70. This is again no. So we increment count. We check 70 and 80 here. This is again no. We increment count. And this condition, count is greater than limit minus 1, is met. So again we go to this part. So is flag equals to true? Now we have a value of false in flag, right? So that means we can go to the next part, which is result is equals to limit divided by 2 plus 1. Alright, so we had a value of 7 in limit. We have now div 2 and we have plus 1. So this part 7 div 2 will return what? This will return the result without the remainder. So 3. Now we have 3 plus 1. That means 4. Result will be set to 4. We have 4 here. Output numbers result. So we output the fourth element, which is 60, and then we stop. So, all right. So this is a testable. This was actually a very long question, and it was kind of annoying, to be honest. Outline the processes involved in the algorithm shown in the flowchart in page 6. Page 6 is basically the previous page. All right. So here we are performing some sets of operation, right? So at first you have seen that we performed a bubble sort. In this specific part, we performed a bubble sort, right? In this part, we perform a bubble sort. All right. Basically, we sorted the array. At first, we took inputs of the array, then we sorted this, and then we printed limit div2 plus 1. All right. So what happens here? We are printing the fourth element. Div2 means if the value. All right. Let's imagine this. Let's say the array had 4 elements. 1, 2, 3, 4 elements. Now the value of limit is input at first 7. Limit represents the number of elements. So we have 4 elements. 4 div2 is going to give us 2, and plus 1 is going to give us 3. So we are printing this. And in this specific code, we are actually printing 60, right? Which is the middle value. So that means we are actually printing the middle value or the median. So let's write it down in words. A set of numbers is stored in an array. The numbers are going through bubbles or in ascending order. The median value is output. All right. Next question. The function length calculates the length of a string. The function length calculates the length of a string. Write the pseudo-code statement to read the context of the text file quotation txt into an appropriate string variable that has been declared. Output the string in uppercase and length of the string. So let's write it down. At first, we need to declare a variable, right? We have declaration statement. Alright, let me just write the full code and then explain. Alright, so at first we have declared sentence string. So this is the variable where we are going to store every sentence of the text file. Then we open file quotation.txt for read. We are going to read the file. Read file quotation.txt sentence. We store every single line in sentence. So we are done with this part. Output the string in uppercase and length of the string. So we output case, uppercase of the sentence, and the length of the sentence. Then we close file. So the last part, close file, is actually not necessary. This is a 4 marks question, but you should obviously include this because we are running file operations. We are opening a file, we need to close this. Now, a database table called soft drinks stores details of the soft drinks sold by a small shop. So we have some fields here. State whether any of the field would be suitable as primary key and give a reason for your answer. So we have name, supplier, container, size, CL, all right, number in stock, reorder level, and reordered. Yes. So here, is there any possibility of any values to be unique? There is no guarantee. So that means no fields are suitable as they are not likely to be unique. Complete a SQL statement to return the number of cans that the shop has in stock. So we return the number of cans. That means, so we have number of cans here, right? Number is 30. So we need to add this. Actually, we don't need to count, we need to use the sum. We need to find the total number of cans. So we sum with number in stock. So we select number in stock, then the name of the table is given soft drinks, where we now need to check the stock part, right? So we have container of can. So we need to return the number of can, right? So here we need to choose container as can, or else there will be a problem. All right, so we add container and then we write can here. All right, next part. A high-level programming language makes use of arithmetic, boolean, and logical operator. State how each type of operator is used. Give an example in pseudocode for each one. So, arithmetic is used in calculation. For example, sum is going to be sum plus 1. This is a possible calculation. Then boolean used for operation with true or false values. For example, swap is equals to true. This is a boolean operation. Let's say if swapped and not empty, the AND is a boolean operation. Then logical used in comparison statement. For example, if A equals to B. Basically, you need to include ifs there. Here for boolean, it's okay if you don't mention if. All right, you need to mention any example, swapped and not empty. All right, next part. So here we are given a flowchart. The list using a flowchart contains this data, and we have to trace this. So let's try this. All right. So we have this flowchart here and the trace table here. So the list 1 to 5 contains this data. This is already given in this flowchart, this trace table. All right. Starting off, A is going to be set to false. So we have A set to false here. I will just write A for false and T for true since we don't have much time. All right. Then B is going to be set to 1. Is list B greater than list B plus 1? We compare these two, 1 and 2. So this is not true, right? 15 is smaller than 17. All right. So that means we need to check this. T is going to be set to list B. So T is going to be set to 15. All right. Now list B is equal to B plus 1. That means this part will become 17, the next one, and this will become 15. All right. A is going to be set to true. A is going to be set to true. All right. Then B equals to B plus 1. This becomes 2. Again we compare. Is list B? That means we have 15. Is it greater than 20? And this is no, right? That means T will be set to list B. So T will become 15 and list B is equal to B plus 1. That means this will be set to 20, this will be set to 15, and A is going to be set to true. All right, and B is equal to B plus 1. We have a 3 here. All right, next. Is list B greater than B plus 1? Now again we compare 15 and 5. All right, third and fourth element. This is no. 15 is greater than 5. This is going to be yes, right? That means we said B is equal to B plus 1. So this, all right. So that means we increment B. This will become 4. Then we have is B equals to 5? No, that means we are going to check again. Now is list B. Then we check 5 and 9. Is 5 greater than 9? This is no. That means T will be set to list B. So T will be set to 5 at first. List B is going to be set to B plus 1. Actually, since these three are happening in a similar order, we can do it in the same line. It's okay if we do that. All right. I'm just suggesting you guys because there are not enough lines in this program, most probably. All right. So let's try. T is going to be set to list B, which is 5. List B is going to be set to B plus 1. That means this part right here will get 9 and this will get 5. And A is going to be set to true. So A is going to be set to true. Is B, and then we increment B. This is going to be 5. Is B equals to 5? This is yes. That means we go to A. Is A equals to true? This is also yes. So we go to this part again. Now we are going to start with false. This is going to be F. B is going to be set to 1. All right. Now is list B greater than b plus 1. So we have 17 and 20. Is 17 greater than 20? And this is no. That means we set t to list b, which is 17. Then list b plus 1. This becomes 20, and then this becomes 17. A is going to be set to true. So we have true here. This was actually 17, right? Then b is equal to b plus 1. This becomes 2. Is this condition met? No. So again we go to this part. Is list b greater than list b plus 1? So we now compare 17 and 15. This is no. Sorry. This is 17 and 15. Is 17 greater than 15? This is true. So we increment b. Now we compare 15 and 9. 15 greater than 9. This is also true. We increment b. Now we compare 9 and 5. This is true. We increment b. Now this condition is met. That means we set a is equals to true. Alright. So, sorry. If this condition is met, we go to this part again, right? Is a equals to a was true, right? So we go to this part again. That means a is going to be set to false. And b is going to be set to 1. Alright. Now, is least b greater than b plus 1? We check the first two, 20 and 17. This is true. That means we increment b. Then we compare second two, 17 and 15. This is also true, so we increment b. Then 15 and 9. This is true. We increment b. This becomes 4. Again, 9 and 5. This is true. We increment b. Then is b equals to 5. This is also true. Yes. So this is met. We go to this line. Is a equals to true? This is false, right? So this is the end. And we have no output in this code actually. Next question. All right, we are now in major 24. This will be the last paper that we do in this video. I might actually post another video with the remaining questions. This video is already getting too long, so let's see. This rule algorithm is intended to allow data for up to 50 people to be entered and stored in a two-dimensional array. The data is their last name, first name, and the city in which they live. Alright, identify the line numbers of the 4 errors in the pseudocode and suggest corrections. So let's see. So starting off, we allow data 50 people to be entered, 50 people, alright, and stored in a two-dimensional array. The data is their last name, first name, and city. That means last name is a string, first name is a string, city is also a string. So we have declare people. So this is declared as real, but this should be string since the data that we enter are all string. So that means this line has an error. And number 1, alright. Declare count as integer, response character, continuous boolean, alright. So for I 1 to 50, we are looping through the array. Then for j 1 to 3, we are looping through the inner array. We set the value to empty. This is okay. Alright. Then we have next I. This matches. Count is going to be set to 100. Alright. We set count to 100. That's kind of suspicious. Alright, that's sus. Count continue is being set to true. Case of. So what's the case? Nothing is mentioned here, right? So this line is definitely wrong. I don't know actually what's the mistake is right now. Output enter the last name. Input people count 1. Alright. Input people count 2, enter the first name. Then people count 3. Alright. Do you want to enter another name? Yes or no? Input response. If response is no, that means continue is going to be false. Else count is going to be count plus 1. End if until not count. Again, this not count, we cannot check this. Count is being set as an integer. So this line must be wrong. So I guess some things are clear now that this line has a problem because this is a while loop. So this line should be while. Actually, this is a repeat until loop, right? We are repeating until something happens, right? So we have to repeat here. All right, until not count. But this is also false. We are using the variable called continue, right? So we should write continue here. So we have one final issue. So let's check the line which was sus count is set to 100. This has a problem because we are using the count inside this array, right? And this should take value from 1 to 50. So we need to start from 1. So this is a mistake. So this part right here should actually be 1. All right. So these are the 4 mistakes. Let's go to the next question. Add the pseudocode that you could add to the end of this algorithm to output the contents of the array. Make sure that the output ends when the data in the array ends. All right. So that means we need to check if the value is equals to empty or not. All right. So let's try this. Actually, just going to write the answer at first. All right. So let's use the index. All right. Since we are looping through the array, we will set index as a variable, which will set to 1. All right. So while we have 50 elements in there, right? So we check while index is less than equals to 50. All right, this is one check. And we also need to check the element of the array, right? So the name of the array was people. We need to check if this was empty or not. So let's say we have people index, and let's say the first element. If this is not equals to empty, all right. So if this is not equals to empty, then only we do something, else we won't do anything. So now we output content of the array. So we output at first we have 3 data type, right? 1 2 3. We have 3 inner array, right? So this is 2-dimensional array. We need to print 3 of the columns. So let's go people count 1, and then we output people, then we have count of 2, and then we again output people with count 3. All right, now we're going to increment count. Actually there was a small issue because we actually use the variable index here, right? So let's just change this, use count. All right, so we now set count is going to be count plus 1, and then we have end while. Explain how you could alter the original corrected algorithm to make sure that the number of elements being added to the array does not exceed the maximum size of the array, 50 elements. So let's refer to the code here. So the maximum value is 50, right? We actually need to check that the count right here, the count that right here is doesn't exceed 50. So here we have one condition given, not count. We need to check another condition, right? So let's say and we need to check that this count, we should repeat until this count is less than equal to 50, right? So we should actually use a variable here because this is a maximum value. It's better if we use a variable instead of hard coding everything, right? So let's write it in words. So ideally whenever we are asking for output, it's better if we actually change it here, or if we add a line here. So if the count is equals to 50, that means we already entered 50 elements, right? We can also try it here. And if response equals to n, we can set continue to false whenever this value is met. All right, that means whenever we entered 50 elements, we can check. All right, so any of this works. Let's write the answer. All right, so declare a variable that is set to the maximum size of the array at the beginning of the program. After line 18, check that the value of the counting variable is not greater than the array maximum variable, and if it is, Do not allow any more entries. Add additional condition to until statement that checks if the counting variable is a maximum. Alright, so we are done up to 2024. So let's not do any more paper in this video. Thank you guys for sticking in. So a few last minute suggestion. I would suggest everyone to try out this question and understand. Even if you do not exactly try fully, you should actually understand why student made mistake or what they did wrong, and this is a learning experience. If you do the hard question, you will get to know where common mistakes are done. I'd also suggest you guys that you should try giving a mock on your own. It might be the February March paper 2026 that recently came out. Also, there are more papers in my video. There is a custom paper in my video. You can try that. The questions are a bit harder than normal, and it is a predicted paper, so you might try that. The solution video is given for both the February March paper and that fast paper mock paper, so try that. It will be very helpful for you. And if you guys like this video, do give a thumbs up, a comment, or please subscribe to the channel. That would mean a lot to me. And good luck to everyone for your board exams. I will try my best to give a part 2, and good luck for your board exam. Thank you. Also, please do check the description box. I will give the link to the question paper and also the solution paper in the description box. Bye bye.